So we spent the last couple of days working with completing the square, which is our method for changing a equation from standard form to vertex form so that we can get more information about it. Today I'm going to show you something called the little formula, which is a little bit of a shortcut to help us find vertex form. So the little formula is a formula for x. And x is equal to minus b over 2a. And this x is the x in the vertex. So you've heard of Elf on the Shelf. This is x in the vertex. So remember when we got the equation in standard form like this, we've got a is equal to 5, it's the number in front of x squared. We've got b is equal to negative 10, and we've got c is equal to 7. So I'm going to start by using the little formula. So that means that I'm going to plug negative 10 in for the b. So if I have negative 10, that's going to become plus 10. And on the bottom, I've got 2 times 5. So that's going to give me positive 10 on the top, positive 10 on the bottom, and that's going to give me x equals 1. Okay? Now, that gives me the first part of the vertex. I need the second part of the vertex. I need the y value. So then I'm going to take my x equals 1, and I'm going to sub it in. And when I sub it into my equation up above here, it's going to look like this. 5 times 1 squared minus 10 times 1 plus 7. So when I do that, I'm going to get 5 times 1 squared is going to be 5. Negative 10 times 1 is going to be negative 10. And then plus 7. And when I add those up, I get y is equal to 2. So now I've got the x part of the vertex and the y part of the vertex. So that means that the vertex is 1, 2. I also need to know which direction it opens. Well, sorry, the other thing that I actually need, that's information that I can get afterwards. But the other value I need is the a value. And the a value is the same a value in standard form as it is in vertex form. So a is equal to 5. So when I know the vertex and the a value, I can write the equation of the parabola in vertex form. So 5 goes out in front because a is equal to 5. And then I put the vertex in to those two spots. So there is the equation of that parabola in vertex form, and we don't even have to worry about completing the square on that one. So here's an example. We want to put this equation in vertex form. We want to state the coordinates of the vertex. We're actually not going to talk about the x-intercepts yet, so we'll cross that out for now. But we are going to talk about the y-intercept and the image point of the y-intercept, and then state the equation of the axis of symmetry in the direction of opening. So I'm going to use the little formula. So remember from here, a is equal to 5, b is equal to negative 10, c is equal to 4. Okay, and remember our formula for the little formula is minus b over 2a. So if I have negative 10 and it's minus negative 10, that's going to change to plus 10. And then 2 times 5 goes on the bottom. So I'm getting deja vu all over again here. X is equal to 1. I'm going to sub x equals 1. And when I do that, I'm going to get y equals 5. 1 squared minus 10 times 1 plus 4. So 5 times 1 squared is going to be 5. Remember, I square the 1 first and get 1. Then multiply that by 5, so that's where that 5 is coming from. Negative 10 times 1 is going to be negative 10. And then I get plus 4 on the end there. And when I clean things up on the end here, when I add them all up, I get y is equal to negative 1. So I'll come over here. Now I know that the vertex is 1, negative 1. And I know that a is equal to 5. So to graph this guy, I got the vertex. Now the y-intercept, you can just find some space on your page for that one. I'm going to do it right up here. If I want the y-intercept, that means I'm going to let x equal 0. And if I let x equal 0 in standard form, look what happens. It's going to be 5 times 0 squared minus 10 times 0 plus 4. And the first two parts end up equaling 0, so the y-intercept is actually 4 there. So that means that this graph will cross the y-axis at 4, or at the point 0, 4. So that's what that's going to be. And once I sketch the parabola, you'll see the image point of that. The axis of symmetry. The axis of symmetry is always x equals, and it comes from the x value in the parabola, or in the vertex, sorry. And this guy is going to open up. So let's sketch this and see what it looks like. So the vertex is at 1, negative 1. And this one, because the a value is 5, the step pattern is going to be 5, 15, 25. All right, so from the vertex, I go over 1 and up 5. 1, 2, 3, 4, 5. And from that point, I go over 1 and up 15. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15. And if we couldn't fit that point on the graph, that would be fine. We just plot the ones that we can fit. So we've got image or mirror points on the other side of the vertex here. So we've got points in those spots there. So when I'm graphing the parabola, that's what it's going to look like. Like that. Just try and put this in the right spot. Remember, this is just a sketch. It's tough to draw these perfectly, but that's what the parabola is going to look like for that. And the y-intercept, you can see our y-intercept showed up here. There's our y-intercept of 0, 4. And the image point is this point here, that is at 2, 4. And our axis of symmetry, I'll put that line on here. So the axis of symmetry comes right down through the middle of the parabola there. And notice that the image point of the y-intercept is exactly the same distance from the axis of symmetry as the y-intercept. So these 2 points are directly across from each other, and they're the same distance from the axis of symmetry. And remember from up above there, our axis of symmetry is x equals 1. Okay, and now we'll look at the last example here. Same sort of thing. I will list my A, B, and C to start with. So A this time is -2, B is -5, C is 3. And a little formula is going to look like -5. And then 2 times -2. So I'm going to get 5 over -4. Okay, so there's my x value. And really, once I get there, that equation is my axis of symmetry. So my axis of symmetry is x equals -5 fourths. So there's my axis of symmetry right off the bat. And then I'm going to take this. I need to find the y value of the vertex. So I plug that into the equation, y equals -2, and then -5 quarters squared minus 5 times -5 quarters plus 3. Okay, so I need to square each number in the bracket there. So -5 squared is going to be 25, and 4 squared will be 16. If I multiply these together, I'm going to get positive 25 over 4. Remember, this -5 has a 1 underneath it, and I multiply straight across there, so that's how I get 25 on the top and 4 on the bottom. So it's going to look like that. Okay? So when I multiply -2 times 25 over 16, and I simplify it, I'm going to get -25 over 8. And then I have plus 25 over 4 and plus 3. I need to get all of these at a common denominator. So -25 over 8. If I change 25 over 4 so that it's 8 on the bottom, I'm going to have to double the 25 to 50. And if I make this an 8 on the bottom, I'm going to have to make that a 24 on the top. So what I end up with here, when I add those together, -25 plus 50 plus 24, I end up with 49 over 8 as the y value. So that means then that our vertex is going to be -5 quarters and 49 over 8. Now you may want to change those to a decimal form so that they're easier to plot. So if you divide -5 divided by 4, you're going to get -1.25. And 8 goes into 49 6 times, and 1/8. So 6.125 is what that one's going to be. So there's my vertex. My y-intercept. Remember, for the y-intercept, when I figure out the y-intercept up here, that's the one good thing about standard form, is that the y-intercept is just the number on the end. So the y-intercept is going to be 0, 3. So when x is 0, y is going to be 3. We've got the axis symmetry. This one opens, if we look at that original equation, it's going to open down. And the step pattern, it's been multiplied by -2. So it's going to change to -2, -6, -10. Let's see what this looks like on the graph. I need to plot the vertex first. So the vertex is, what's going on with this guy here? This guy's not good. I just realized that the graph's a little bit wobbly here. All right, we're stuck with it. Let's go with it here. The vertex is at -1 1/4, which is about there, and up to 6.125. So 1, 2, 3, 4, 5, 6, 1, 2, 5. So there's my vertex. So that's -1.25. And that is 6.125. There's the vertex. It's opening down, and it's got a step pattern of -2, -6, -10. So from here, I go over 1, and I go down 1, 2. That puts me in that spot right there. I do the same thing on the other side. I go over 1 and down 2. So it's right there. Okay. This one has a y-intercept of 3, so that means it's going to go through this point. That also means that it's going to go through, and the distance that one is, well, we'll figure that out in a sec here. Let's do the other step pattern points. So if I go from this point here, this time I'm going to go over 1 and down 6. So over 1 and down 1, 2, 3, 4, 5, 6. So I got a point there. And from this one, I go over 1 and down 6. So I'm going to end up right there. And the other one's down 10. That's going to be right off my graph. So I'll just leave it as it is there. And that's what the parabola is going to look like. My axis of symmetry I need to put on here. So my axis of symmetry, the vertical line that goes right through the vertex. So remember, our vertex there is at -1.25, 6.125. That's our vertex there. Our axis of symmetry is x equals -1.25. Okay, and we've got this point here that's at 0, 3. The point on the other side, so there's a point on the other side that is the mirror image of that. So it's straight across from it. We know that that one is 3 high as well. The x value for this one is the same. This point is the same distance from the axis of symmetry as the y-intercept. So the y-intercept is 1.25 away from the x-axis, sorry, the y-axis. So I'm going to go another -1.25. So this is going to be at -2.5, and 3 is where that one's located. Okay, so we're going to talk more tomorrow about the little formula. It's a little bit more straightforward than completing the square, and it can be helpful for us. So we'll see you tomorrow.